question number 11. Where will you place a load of 120 kilonewton on a beam of 6 meter span to get one reaction twice the other? See, this question is conceptual, means we hadn't solved any question related to like this, where you have been asked a question in such a manner where we have to get the length, or you can say the distance at which the load has to be placed. So let us see what we can write for this question. I will write the data for question number 11. Here it is given, where will you place a load of 120 kilonewton on a beam of 6 meter span to get one reaction twice the other? The beam type is not given, so I will consider it as a simply supported beam. I'll say it is beam AB, having its span as 6 meter. Now, it is said that where will you place a load? Where means the distance. Load is 120 kilonewton. So what I will do here, this load I will call it as 120 kilonewton, and since the distance is not given, I'll say that it is at x distance from point A. To get one reaction twice the other, since simply supported beam is there, we would be having two reactions at the end. Here it is given that for this condition we have to take one reaction as twice that of the other. So I'll say that let RA be the reaction which is twice of RB. I'll say this condition. Now we have to find this distance x, that is at what distance we would be placing the load. So x is the unknown. Now I'll write the solution for this question. I'll say that since using the conditions of equilibrium, I will use the first condition. Summation of Fy is equal to 0. Upward force is positive and downward force is negative. Therefore, here I have RA plus RB minus 120 because it is down. Therefore, RA plus RB is equal to 120. This is my first equation. The second condition I will use, that is to calculate the summation of moments, but before that, here it is given that one reaction is twice that of other. So I will use this condition that therefore instead of RA I will write down 2 times of RB. I'll say that it is given. Now therefore this will be 3 RB is equal to 120. Therefore RB is equal to 120 divided by 3, and that will give me 40 kilonewton. Now I'll say that since RA is equal to twice of RB, it was given that the one reaction is twice of that the other. Therefore RA is equal to 2 into 40, that is 80 kilonewton. So now I have both the reactions, but here reactions are not asked. We have to calculate the distance of this load. So how I will calculate this? I will be taking moments either at point A or at point B to calculate the distance. In this case, I'll say taking moments at point A because I have shown the distance with respect to point A. So I'll say that now the second condition of equilibrium, that is, since sum of moments of all forces are equal to 0, therefore summation of moments about point A is equal to 0, where clockwise moments are positive and anti-clockwise moments negative. Therefore, here I will write down RB, and it is producing anti-clockwise moment. So minus RB into 6, then plus I'll say W into X. So it is plus W into X, that's equal to 0. Hence, instead of RB, I will write it as 40 because I've got the value minus 40 into X, 40 into 6 plus W is given as 120 into X is equal to 0. So this will give me a value of minus 240, and if I shift it onto the other side, that will be plus 240 divided by 120. So therefore X will be 2 meters. My answer. So if I look into the question, here they were saying to calculate the distance of load from point A, or you can say from the fixed point, or this value comes out to be 2 meter. It means this load 120 kilonewton would be placed at 2 meter distance from point A. So from point B it would be at 4 meter distance. So the problem gets completed. We have calculated the distance.